Our new chapter is gradient of the straight line. From the section 2.1, we are going to discuss these topics: equation of the straight line, what is the gradient, and what is y-intercept, and some details associated with these three topics. So first of all, let's consider two photographs. I'm going to add it. This is the photograph of two ground. We can see clearly that one is steeper than the other. And we all know that the steeper the ground is, the more difficult it is to walk up. So basically this gradient is the measures of how steeper the slope or the ground is. Alright, and how can we measure the gradient? Simple, we have a formula which says that gradient is the ratio between vertical change and upon horizontal change. Vertical change is basically, I am going to write it down like this. See, this vertical change is basically the rise upon run. So we can say that gradient is the ratio between rise upon run. Now how high the slope is and what is the vertical change of the slope. This gradient is also denoted as m. Alright, and we can write this m in the straight line in the form of the equation y is equals to mx plus c. We have discussed this before, the equation of the straight line. So this equation of the straight line can be written in this form, where m is the gradient and y and x we already know are the variable, and c is basically y-intercept. Now what is y-intercept? In a graph, when a straight line cuts the y-axis at a point, this point is called y-intercept, and we can also say that y-intercept refers to the y coordinate of the point of intersection of the line with the y-axis. So either you understand it in that way, or the simple way is this, that when the straight line cuts the y-axis at a point, suppose at any point 1, 2 and 3. So here 3 will be the y-intercept. Clear all these three answer of these questions. Now one more thing is left. That is, what is positive gradient and what is negative gradient. Positive integer is when a slope or a straight line move upward from left to right. It's very important to remember this. So when the line moves from in upward direction from left to right, it is positive gradient. The gradient of this line will be positive, and the negative gradient will be exactly opposite of the positive gradient. So negative gradient will be when a straight line goes down, or when the slope goes down from left to right, the gradient of such slope will be negative. So I hope that I have cleared out all these concepts. If you have any queries and any problem, you can write in a comment box. Practice now part A. Find the gradient of each of the following line. Very simple. All we have to do is we have to find out 2 points on this line. Alright, a point such a way that we can make a right angle triangle. So I am going to take 2 very easy points, A this and B this. So this and this, and I am going to make a right angle triangle. Let's call this point as O. So the triangle AOB, we know the formula of gradient, that is, I am writing it down in a short form. Gradient is equals to rise upon run, right? So rise is the vertical change and run is the horizontal change. Rectangle triangle AOB, rise is OB and run is OA. See? How to calculate OB? Simple. We know the coordinates of A, that is 0, because there is a y-intercept, x is 0 and the line cuts the y at 2, and the coordinate of B will be on x. We first we have to write the coordinate of x, that is 4, 14, right? And similarly the coordinate of O will be 4, 2. Calculate OB. Simple. Let's treat this as a line segment, and to calculate this line segment we have to minus initial value from final value. Always remember, initial value from final value. So final value is 14 and initial value is 2. Now here in the vertical change, what we have to do, OA, how will we calculate OA? Again, final value minus initial value. Final value is 4 and initial value is 0. See, 4 minus 0 is going to be 12 upon 4. 4 ones are 4. 4. 3 is 12. Required gradient is, I am going to write it down like this, 3. The line is moving, although it is not required, but I am writing it down since the line is moving upward from left to right, from left to right. So the value of the gradient will be positive, right? Hope that I have explained the previous part clearly and in detail. So let's do these 3 remaining part of practice now. Question B, C and D very quickly. So here again what are we going to do is, it's already this line is already cutting y-intercept and x-intercept, I am going to take these 2 points A and B, and it's already forming a right angle triangle, and it would be very easy. So triangle A O B, because we don't have to find out the coordinate of the third point of the right angle triangle. We already know it's 0 0. So in triangle AOB we have to find out the gradient, which is, how we will find out the gradient? Rise upon run. See, rise upon run, and rise is OA and run is OB, and we know that in OA, what is the final point? Final point is 4, initial point is 0, and in OB the final point is 8 and the initial point is 0. So 4 minus 0 will be 4, and in OB 8 minus 0 will be 8. Simplification 1, 2, and this is going to be, gradient is going to be half. But I have explained to you that if the slope is coming down from left to right, then the slope will be negative. So it's going to be, final answer is going to be negative half. See, now let's get back to another part, that is C. In C, I am going to take two very easy point. Alright, let's take this point -3 here on y intersecting y-axis at -3, and this point 2 intercepting x-axis at 2. So let's make a right angle triangle at this point, okay, and this point will be 0. We will find the coordinate of this 0 as 2, -3. Okay, now gradient, we know rise upon run, which is going to be, rise is O A upon O B. So let's calculate the value of OA and OB. For OA, final value minus initial value. See, final value is 0 and initial value is -3. So 0 minus -3 over OB. Will be 2 minus 0. Okay, so 2 minus 0, it's going to be 3 upon 2, and we know that 3 upon 2 is one whole number, 1 upon 2. Now see, the slope is going upward from left to right, that means it's going to be positive. So our gradient is going to be positive one whole number, 1 upon 2.
in data. Thank you for watching. Subscribe for more updates.